This chapter traces the evolution of ideas about space and the senses, exploring how historical and philosophical perspectives have shaped modern cognitive neuroscience. It provides context for understanding the central questions of the book, how the senses contribute to spatial perception and how they relate to each other. Key historical ideas. Socrates, as recounted by Plato, believed that spatial concepts were innate and could be revealed through reasoning. He demonstrated this by guiding an uneducated slave boy to solve geometric problems, suggesting the presence of inborn spatial knowledge. Immanuel Kant describes space and time as a priori intuitions, meaning they are fundamental frameworks for human perception, independent of experience. In contrast, British empiricists like John Locke, George Berkeley, and David Hume argued that knowledge, including spatial understanding, is derived from sensory experiences. The Molyneux problem. Posed by William Molyneux to John Locke, this problem asks whether a person born blind, who later gained sight, could recognize objects previously known through touch. Historical evidence, such as von Senden's studies of cataract patients, initially suggested they could not. Later research showed the brain requires experience to develop the mechanisms for visual spatial perception. Weber and Fechner's psychophysics. Ernst Weber and Gustav Fechner studied the relationship between physical stimuli and sensory perception, laying the groundwork for experimental psychology. Weber's law describes how the smallest detectable difference between stimuli depends on their initial intensity. Weber's two-point threshold technique demonstrated varying tactile sensitivity across different parts of the body. Von Helmholtz and unconscious inference. Hermann von Helmholtz proposed that perception involves unconscious inference, where sensory inputs are interpreted based on past experiences. David Katz and touch. Katz emphasized the neglected importance of touch in perception, describing it as a multisensory experience involving movement, pressure, and proprioception. He introduced the idea of composite impressions, where touch integrates inputs from various sensory modalities. 20th century advances. Gestalt psychology. Gestalt psychologists proposed that perception is holistic, emphasizing the innate tendency to perceive global configurations rather than isolated sensory inputs. However, Katz criticized their focus on vision and argued that touch involves different perceptual processes, such as scanning and movement. Behaviorism and conditioning. Early 20th century psychology emphasized learning through association, for example, Pavlov's conditioning, with limited focus on innate spatial processing. J.J. Gibson's ecological approach. Gibson rejected atomistic views of perception, arguing that sensory systems actively detect invariant features of the environment necessary for spatial orientation and action. He introduced the concept of affordances, where objects and surfaces are perceived in terms of the actions they allow. Implications and lingering debates. The debate about whether spatial concepts are innate or learned persists, though modern science emphasizes their interaction. Theories differ on whether perception is direct, as Gibson argued, or mediated by cognitive processes like inference and memory. Advances in neuroscience have shown that spatial perception involves integrating inputs from vision, touch, and other senses, challenging earlier dichotomies. Conclusion. The chapter sets the stage for the rest of the book by highlighting the complexity of spatial perception and the role of historical theories in shaping contemporary research. It argues for a more integrated understanding of how different sensory modalities contribute to our experience of space.